Hello, and welcome back to the THE student. We have a very exciting institution with us today, all the way from Indianapolis, in Indiana, USA, Kelley School of Business, who are going to be talking to us about their fantastic AI programs. So, just some general house rules. There is a Q&A box at the bottom of the Zoom if you have any questions. We'll be running for approximately an hour. And yeah, that's it from me. So I'll pass over to Alex Barsi Lopes now to get things started.
Thank you, Amelia. Appreciate that. Hello, everybody. For those of you here, for those of you watching this recording, it's a pleasure to be with you. My name is Alex Barsi Lopes. I am Associate Chair for Kelley Executive Education Programs at the Kelley School at Indiana University. So I manage our online programs and certificates. One of them being our MS in IT management. I'm a faculty here at Kelley. I'm a clinical professor, and I have several different roles here. We're delighted to be speaking with you about AI and what in the AI world is going on. That's the title. And this is a lot of our, essential things. It's a little snapshot of several of the things that we cover in our MS in IT management. It is also some of the content that we cover in our MS in business analytics. And we also have an MS in finance, and all those programs are online. I'm going to go very briefly and display our QR code if you are interested in getting some additional information about the programs. And I'm going to pass to Arlene. Arlene works with me, and she manages a lot of the applications for the programs, and she can talk a little bit about that. Arlene, please go ahead.
Hi, thank you, Alex. As Alex mentioned, my name is Arlen Llewellyn. I'm the Assistant Director of Recruitment here at Kelley Executive Education Programs at Indiana University. And as Alex mentioned, we have an MS in IT management that is being sort of primarily highlighted today. We also have an MS in business analytics and an MS in finance. And I look forward to answering any questions that you may have about some of those program details. As you're listening to Alex's presentation, if you're browsing the website, you can access through this QR code. If you have any questions, you can drop those in the Q&A, and I may just reply to you as the presentation is going on, or we'll address them at the end. And just excited for you to hear about this presentation that Alex has made, and look forward to answering any questions that you may have. Thank you very much.
Thank you so much, Arlene. Much appreciated. So let's go straight to the agenda for today. And essentially, we have this agenda around the 5 main topics, right? First of all, is discussing how we got here, right? If you're talking about AI, right? And this is something I have been teaching AI well before it became a big, fashionable topic. I have taught AI for business for 6-7 years now. My courses have been essentially considered some of the most innovative courses by Poets and Quants, which is a publication that evaluates graduate degrees in the US. And so it's important to just kind of how we got here, right? And eventually going to move towards where we are now, right? In terms of applied AI and generative AI. After that, we're going to be discussing about what are the main risks associated with AI, and there are many of them to account for. And then from that, we're going to discuss why do most projects fail? Why do most AI projects fail? Before finalizing a presentation, right, with a discussion about how to succeed. So if you have an AI project, how exactly can you be successful in that initiative? So we are going to start, right, in terms of where did all this AI stuff come from? And essentially is really the confluence of these 3 developments that have happened in the last decades. First of all is big data, right? this ability to capture immense amount of data, right? Have these super vast data sets and the storage capabilities to deal not only with tabular data, but with unstructured data as well, and videos and images and so on and so forth, right? So that allows us to really have much more data to train our systems, AI systems, to train the models as necessary. The second big trend is computing power, right? And how we have this exponential growth in computing power. And one of the things is interesting because we thought, for quite some time that computing power was kind of become a little bit more stable, right? Because of physics, the limitations in space and in interference and so on and so forth. And not even talking about quantum computing, there's a big development right now, but we have been able to keep, pushing the boundaries in terms of computing power, in terms of new designs of chips, right? Back, some time ago, we had this discovery that GPUs, because of this parallel processing, were much better to train data sets, to train models than CPUs, right? And that's essentially when we start seeing companies like Nvidia, right, becoming extremely valuable because that's what they have been doing for many years. I remember us, putting together my own machines with Nvidia, graphic, chips, right? And that's something that has evolved over time, and this computing power keeps, pushing the boundaries even now with new releases with more and more powerful processors. And then you have the algorithms, right? This idea that you have new ways of doing things, new techniques to apply to this data. And those algorithms, some of them have been around for quite some time, but the big difference is now we have enough computing power and enough data to make those algorithms helpful, right? I, played around with um, neural networks back in the 90s. And at that point was an interesting concept, but not helpful at all, right? But once the other trends with big data and computing power start to really converge, so all of a sudden, those neural networks became much more powerful, much more helpful even, okay? So and this is where we stand, we have been, looking for, right? So there is this kind of a two main categories of AI models, AI solutions, one being machine learning or statistical machine learning, right? So we have things like supervised learning, unsupervised learning, reinforcement learning. And in those systems, there's a lot of a human, judgment, human interference, right? Human setup, right? So if you're talking about even unsupervised learning, despite the name, right, the human agents are doing a lot of the work, even though we don't quite know what the results are going to be, right? So perhaps you have a cluster of recommendations, right? So it's a classic unsupervised learning problem is, well, I have a bunch of people that are my customers, for example, subscribers, let's say Netflix, right? And I want to categorize people to provide recommendations to them. So this is what an unsupervised learning problem is, and you have some great techniques to deal with that. But it still requires a lot of a human, kind of a guidance there. On the other side, you have deep learning, right? And deep learning essentially is based in neural networks, and you have a variety of different approaches like convolutional neural networks or CNNs. Those are dealing with images, right? Image tagging, image recognition. So those are the kind of things that CNNs do. Recurrent neural networks or RNNs, right? Time series, generative adversarial networks, GANs, diffusion models. Both of those types go more in terms of image generation, right? A little bit more kind of almost like the old style of image generation. Again, all of those are still very helpful. They're still in production, right? And this is how we start really seeing the potential of neural networks, of deep learning, until eventually we got to transformers. And transformers are relatively new as a development in terms of neural network, in terms of models, right? And the idea behind transformers is really looking at this multidimensional space when you have correlations between objects, right? So if you define a transformer very quickly, essentially, well, is a neural network that allows you to predict the next word, right? It's kind of the basic definition. In reality, right, is a multidimensional space where everything has different weights, right? And that's when you associate, for example, small to smallest because they are occupying a kind of a closed region is this multidimensional space. We also associate small with big because again, they are essentially in this dimension there, right? They are kind of close together. So that's essentially a situation where the more data, right, the more parameters we have, the better the predictions are, the better the outcomes are, because we have more correlations, we have a more powerful, data sets, we have a more powerful ability to predict, right? Now, transformers are the basis of large language models. And that's when you see things like ChatGPT, Copilot, Gemini, and many, many others, right? But what is interesting right now is that transformers have been used beyond, right, chat, beyond, text or voice recognition. They are being started to be used in a variety of areas that perhaps were much more the domain of other types of neural networks, right? And sometimes you have, some of these different neural networks working together with transformers to, improve and benefit the results, right? So this is where we have been, right, in terms of this evolution of different types of essentially big data, computing power, but a lot of these new changes are in algorithms. Now, this is where it came from, right? So the question now is where we are, right? And where we are in both applied and generative AI. So this is some interesting recent stats from some of the McKinsey tech trends. And here I'm looking at the comparison of investments in Gen AI, industrialized machine learning, and applied AI, right? So generative AI is what we all know, right? Essentially, we have those models that can be predictive, right? And it has gotten a lot of attention, obviously, right? And a big amount of investment in equity investment, and also a big attraction in terms of job postings that are somewhat related to generative AI, right? So it's a big, it's ascending, getting bigger in terms of size of those initiatives, right? So it's very interesting things going on there. When you talk about industrializing machine learning, there's a lot of a big upshot here, right? A big, jump, right? It is still small, but this is the area that you might be seeing more like Industry 4.0, right? Things that involve like manufacturing. So it's a little bit more constrained in terms of the application of those technologies, but the potential within those constraints inside those industries is very, very powerful as well. And then you have the applied AI, right? In applied AI being the more traditional use of AI in a variety of different domains, right? It might involve statistical machine learning. It might involve some more traditional neural networks, deep learning, right? So things that have been a little bit more established, and this is where you should have a huge amount of equity investment. But on the other hand, there's a little bit of a decline in terms of job postings, right? So, because in part of it is because generative AI is putting a lot of attention to that particular area. But overall, what you see is that all those areas, right, applied AI, industrialized machine learning, generative AI, are still going up, right? They are still increasing the level of investment. So there's a huge still amount of potential within AI and AI initiatives to really attract a lot of interest. So let's see, but there are some issues, right? One of the potential issues that we have seen is that we are running out of publicly available data to train those models, right? So of course, you probably know that large language models are trained, by scanning the internet, right, and finding new data. And quite frankly, we are getting to the tail end of the availability of public data, right? That has not been used yet to train those models. So that is a concern because these models need more and more data to keep being refined. And what happens when we stop having public available data, right? So one of the alternatives that people are considering is this idea about synthetic data. And synthetic data essentially means generative AI models creating synthetic data that's then used to train generative AI models, right? And one that is a trend that is sure be very controversial, and in some early indications might not support that as an avenue to move forward, right? But it doesn't really mean that you should just stop, right, and stop doing what we're doing right now. It means really looking for some alternatives, right? And the one alternatives are essentially these more organizational data sets, right? So using some techniques related to retrieval augmented generation, or RAG, that essentially looking at internal data sets and allowing the organization to kind of go side by side, in which part of the problem might be managed by large language models, but part of the application in terms of data extraction, right, and looking for insights might actually come from organizational data sets. So one potential application, I was attending a presentation by the University of Pittsburgh School of Medicine, right? And essentially looking at how they have a lot of diagnosis data, right? A lot of symptoms, a lot of body measures, right? And a lot of correlation between those, and some potential for some diagnostics, right? So the idea that they are doing is, again, using part of this large language models to do some of the work, but then really going deeper into their own data, right, or data that belongs perhaps to a consortium of hospitals, to really specialize and get the best potential outcomes possible to work with diagnostics, right? So it's really this combination between those large language models and these more specialized data sets that together can provide better results for the users. One interesting thing is that despite this big constraining data, right, um, we still don't know even how to evaluate how good those large language models are, right? So one side is we have this some multiple recent reports in the news that those new versions of these big models that you see on the marketplace right now, they are not evolving as quickly as they did before, right? So there's some indications that some of them might have kind of reached a potential plateau, where a new version is not necessarily extremely superior to the previous version, right? There are some really big jumps from GPT-2 to GPT-3, right? To GPT-3 to GPT-4. And the next models might not really have that much of a jump. So that's a concern in the industry right now. It's like, hey, can these models keep evolving forever, or there is some sort of limitation? On the other hand, right, those models are still very, very good, and they're getting better, right? And they're getting so good that it's even hard to figure out how good they are, right? What is the right benchmark to apply to those models? Back in the day, and by back in the day, you're talking about a couple of years ago at most, right? Some of the comparatives, like, well, hey, can this model write a good essay for an admission exam? Can this model write essentially, pass a bar exam, a law exam, right? And in many cases, say, well, yeah, they can, right? They can for the most part. Now the benchmarks are even like, hey, can these models pass a qualifying exam for a PhD program, right? And what you see, like, yes, they can. So you're not, kind of having new versions, but you are kind of working around the current versions with different approaches and techniques, right? Some doing some deep explanation about how the reasoning takes place. So all those things are contributing to these models essentially keep improving that. Which industries do you think that will be most disrupted because of LLMs? So what we are seeing right now is that this disruption is actually not as significant as people first anticipate. And I'm going to explain a little bit why this is the case later, right? What we're seeing quite a lot is essentially models that are much more supporting, right, the activities that people are already doing, but perhaps making people a little bit more efficient. And I will explain why we did not get that disruption yet, right? We have seen some really interesting examples of things. Education is one of them, right? We can do some really interesting stuff in the education realm. We have seen a lot of interesting potential applications in consulting, professional services as well, right? Some of the customer relationships in finance. So the applications are vast. It is just that we're still quite not there. And I'm going to talk a little bit about that later. And thank you for the question. I appreciate that. All right. So that is where you are right now in terms of interesting development, which is the idea about agentic AI, right? So agentic AI is really this confluence between organizational needs, AI models, and almost citizen development, right? So those are tools, and there's a lot of companies invest on that. Microsoft, SAP, ServiceNow. SAP has Joule, right? Microsoft has LinkedIn agent, has a SharePoint agent, and et cetera, et cetera. And it's really this idea about, hey, I need some support for the tasks, right? So going back to the initial question, right? I'm still doing the work, but I want to speed up some of my processes, right? So for example, going to be meeting with a client, right? I need to figure out what's the best proposals that I can put together based on previous purchase orders from that client, right? That is something that agents can really do well, as long as you supervise the results later, right? Pull together a bunch of different trends from clients, right? And give me a competitive proposal for the next order for this particular client. So that's the kind of thing that agents do well. So preparing for meetings, right, is almost how you treat this as your super assistants that can speed up some of the processes. And there is a lot of investment in this area. We have been putting together some agents internally here at Kelley, and they're actually pretty easy to create and can be helpful in a variety of situations. Creating some class, chat bots, and they don't require a lot of technical background to be set up. The final thing in terms of where the state is, is a lot of these different developing things like DeepSeek, Qwen, right? DeepSeek is a startup, Qwen is Alibaba, and these are all new open source models. And they're very powerful because, again, they're open source. So they can be, reused, right, by a variety. You can go to Hugging Face and see these models and applications there. So they're very interesting because in many cases, some of the best examples, the best models from OpenAI and Google and Gemini, right? They might be better, right, than DeepSeek in some use cases, but the issue is that DeepSeek and Qwen, they get close enough at a much lower cost, right? So in many cases, what you can see is perhaps a democratization of access to AI using those open source models, right? Is still with perhaps a little bit of a gap in terms of performance, but perhaps not a significant gap in terms of the use cases that people are going to be looking for, right? So a lot of development in these areas is essentially a lot of new models, a lot of new approaches. So this is a super exciting time because for quite some time we thought we we're going to have this linear, right, progression in which, hey, we put a bunch of servers, a bunch of GPUs together, and the more we get, right, the more we have trained data. So that's this linear process. But all of a sudden, right, DeepSeek and others have opened, hey, maybe it is not always like this. We can have different alternatives that can facilitate, the use of AI, but at a fraction of the cost. So stay tuned, essentially. That's probably the best thing I can talk about that. So let's talk a little bit about risks, right? And A couple of risks that you have to be aware is, first of all, is really ethics and regulations, right? Which is how this is so unsettled right now. So if you think about ethics and fairness, and that is a problem because we don't have essentially a universally right agreed definition of what ethical behavior is and what's fair behavior is, right? And in fact, and I have done this in my classes. I have asked what is fair for you, right? And I have had classes with 45 different people, 50 people, and I had 45, 50 different answers, right? Some variations over the same theme, and sometimes close enough, but different perspectives or different judgments, what is a fair situation or not. And there's no surprise because you can think about fairness in terms of the process being fair, about the outcomes being fair, and even that big classification might have some permutations between them, right? So that is the problem that you see in terms of risks because we don't have an agreement, right? So when we're building solutions, regulations, what's considered ethical, might change from inside the organization to outside the organization to a government, right? Perspectives and so on and so forth. One of the most advanced frameworks that we have right now is for the EU. Why the EU approved a regulatory framework for AI that essentially was based on the risks, right? Systems that bring more risks and more implications, they are scrutinized more. Systems that have fewer risks and fewer implications are scrutinized less. So it's a very clever way to deal with that. Except that many people question right now if it is actually enforceable or not because the technology is changing so fast. Interesting that this approval of this framework, right, was actually delayed because as they were getting ready to vote, ChatGPT was released to the public. And then eventually pretty much everybody said, oops, right? We have to redefine stuff internally because that carries with a different types of risks in certain situations that we have to account for. So it's a constant, right, discovery of new things. And again, we need experts to judge the risks. So it's probably the most advanced framework. We still don't know if it's applicable, if it's enforceable or not. So you are still left in this a little bit of this uncertain situation, right? If you are pursuing a solution about what is acceptable from an ethical and regulatory perspective. Of course, we have tons of biases that we have to account for. And the interesting thing is that many people actually consider AI systems to be less biased, right? Because there's no human presence. We did an experiment at the Kelley School some time ago in which we asked people, hey, for your performance evaluation organization, would you trust more this person, right, as a template, a persona there, or an AI system, right? And many people thought, wow, the AI system, because the AI system is not going to be biased, right? And for people who understand how AI systems operate, we're like, no, there are a lot of biases here, right? The data sets might be biased that we're using to train our models. The selection of models might be biased. The insight selection might be biased. The way what we're going to do with the insights, it might be biased. So you have to be super careful, right, dealing with that. And again, there are many biases in humans, and it's natural that some of those biases are going to be making their way to the systems themselves. One classic example is facial recognition, who for the longest time, right, white males would be recognized better than people from a different gender or people from a different complexion. Why? Because some of the original data sets were pictures of people working in California in computer labs in the 80s, right? Where most people were white males. So again, they kept using this like, oops, it's great for white males. It does not recognize very well if you are perhaps have a different complexion and you are a female. So we have to be very aware of those risks because again, there's a lot of reputation effects and essentially damaging people in general in terms of the outcomes. One big issue, right, that happens with a lot of AI systems is this reliance that you have, over-reliance in many cases, right? So in many systems, we start seeing them working well and, for a while, and it's virtually impossible for the human agent that is perhaps in charge of supervising that to keep the level of attention that's necessary, right? And when those systems fail, which might not really be a common occurrence, right? The consequences might be catastrophic, right? So we don't, we just humans cannot be asked to keep focusing all the time, right? With something that's working for the most part well, because eventually they're going to not pay attention. They're going to just trust. And that's when disasters can happen. And of course, another risk related to that is who is liable, right? Is that the person who was not paying attention? Or is that the system that failed, right? And again, we still don't have as much of a legal framework regarding that. And finally, one of the interesting things about AI models is that we don't know how they work, right? I'm going to repeat this. We don't know how these systems actually work. So neural networks are not programmed, they are trained. And there's interesting efforts in terms to understand how they actually work internally, right? Anthropic does a lot of interesting research about that. And their conclusions like, oh, this is really, truly interesting, right? We never expected that to happen, right? When they're able to capture what happened. So that is a big problem in many cases because that lack of explainability also means that we cannot debug stuff. If something fails, it's extremely difficult, if possible at all, to figure out, okay, that's the reason it failed. Now I can fix that, right? Because we sometimes you don't explain, there's no explanation why it failed in the first place. So there's a lot of research looking about how those models work, right? That allow us to kind of understand them better and try to figure out, what the paths they take when making a judgment, right? We right now we don't. I never seen a technology that we use so in such a widespread mode where we actually don't know how it works internally, right? But that's the situation right now. Should we stop using that? No, but we should understand that, there's still some mysteries involved, and especially with the lack of explainability. So why do most projects fail, right? The most projects fail. This is a kind of a hype. I love to see this. This is all McKinsey, headlines, right? State of AI in 2023, generative AI's breakout year. 24, Gen AI adoption spikes and starts generating value. 25, right? Gen AI is here, but where are its users, right? So that's a lot of hype. And Infosys did a very interesting, they have this AI radar, kind of monitoring the AI situation. And they look at 5 different factors. And what they concluded, right, in strategy, governance, talent, data, and technology, what they concluded is that only 2% of companies are good in all those 5 dimensions, right? Only about in their own study, the same similar study, similar radar, a survey, they surveyed thousands of companies, right? Only 19% of AI projects, most of the expected value has been achieved. And there are estimates in a variety of different, publications that indicate that only between 80 and 90% of AI projects, right? Most of all these projects never go beyond proof of concept, right? So try something, but it never makes into production. So why this happens, right? First of all, lack of strategy. People don't know where they're going. They don't have a strategy for the use of AI, right? We don't know what the future state is. We don't have business cases and metrics to assess the benefits that are coming from a particular AI project. And because we don't have metrics, it means that the project fails. All of a sudden, we don't have the capacity to learn from them because we never have good metrics in the first place. Secondly, most organizations don't have a proper governance structure, right, to deal with AI risks. We don't understand the risks in depth, right? Some organizations are good with that, right? There's always a range, but many organizations don't have any idea, right? Any systematic idea about what are the risks involved in any sort of AI initiative, right? So we want to minimize those risks, but those risks might affect individuals. Those risks might affect organizations. They might affect society, right? And most organizations don't have the proper governance. They don't have the right people that essentially looking at those issues and figure out, yes, we should not do this way because there are potential negative implications to our clients or customers or users, right? So we're still lacking a lot of that understanding, right? About risks, right? Having a proper structure to assess risks. Now, interesting enough, if you look at the Infosys reports, right, the talent is starting to emerge, right? But we should know what it means to be talented in AI. And again, if we ask a bunch of different people, we're going to have a bunch of different answers, right? So we're looking about, hey, we want you know, we see all this nice, pronouncements saying, oh, we need to get people with more AI skills. Like, okay, what are those AI skills? Explain to me what exactly you're talking about, right? So are we talking about AI technical skills, like deep technical skills that allows you to do some modeling, understand, large language models or other models in detail, right? We need some people like that, of course, right? Or are we talking about people who understand how to use AI? Right? I'm good in prompt engineering, right? I'm good in understanding how agents work so I can facilitate my work, right? Or maybe both. So with a lack of definition, I should kind of trying to get a sense about that, right? We should kind of tap in, well, we're going to put a seminar here together, we're going to do prompt engineering here, right? But not really trying to go deeper into that issue from an organization perspective. And of course, there's a huge generational gap in place, right? Younger people, I see my younger students all the time, right? They have been using AI for a while. They're very good. They might not know the implications of a misuse of AI, but they're pretty versatile in terms of how they use that, right? Where sometimes in organizations, we have maybe some senior people who are just not as comfortable with these new technologies, right? So we have this generational gap that sometimes have different implications. And of course, different industries are going to require different, expertise, right? Sets of experts. So, we are getting better in understanding, AI talent, but we're not quite there yet in terms of what is really necessary for a given organization. Then data, right? That is the Achilles heel of many AI projects. And I cannot tell you how many times I have seen, well, we have this great strategy, we have these great insights, we know the questions that we should ask, but then you realize you have no data to actually get those answers, right? Data is the lifeblood of AI systems. If I don't have good data, I just cannot get any positive outcomes. And most organizations do not really have, I mean, this has been a problem like for decades, right? How to get better data strategy, data management, data governance. It's just that has been aggravated by the presence of AI, because without data, I cannot have AI, right? And what happens is that in many cases, right, projects fail because people got to the stage, okay, that's fantastic. We know what we want to go do and have the metrics and all, right? Let's now execute. And then people realize they just don't have the data in place to actually make true those predictions about that AI project, right? And two things could happen, right? On the go ahead and not realize that, and of course the results are not very positive, right? Or they essentially say, well, we have to do a lot of a pre-work to eventually get to the point in which we can use data. And that's another big impediment, because all of a sudden that project is supposed to take X amount of time. Now it's taking much more time. And people essentially lose the patience and say, well, you know what, we tried. Proof of concept, abandoned. Now, technology itself might be the easiest part, right? Because that's where we start to see a very established tech stack for applied AI and an emerging tech stack for generative AI, right? No matter if you're using, Gemini or Google Cloud Services, Azure, right, or Copilot or OpenAI, we start to really have some nice services that we can wrap according to particular problems, right? And many of those solutions are freely available in the marketplace. So our role becomes much less of let's invent new things, let's develop new things, but many of the technical roles in a business role becomes less orchestrate, right? Let's pick this particular platform with this particular data sets, with this particular model, this particular interface. Let's assemble everything together in a way that makes sense to our organization, right? So what can be a big limitation can actually, of course, requires more investments, but that's why we have DeepSeek and Quen and others, right? Is really thinking about how can I think about this in a very, comprehensive way to orchestrate services instead of trying to reinvent the wheel inside our organization. So how to succeed? And in this section is a lot based on many interviews and conversations with students, conversations with organizations, visit to organizations, right? I traveled the world. I was in India a couple of weeks ago. I'm going to Korea in a couple of weeks. So it's just talking with people, right, what they are doing on the ground, and talking with former students and current students and consultants, and trying to come up with things that make sense in terms of recommendations about how to succeed. And we're starting to see a little bit more of that. And part of that is the realization that is not about the technology, right? Technology is actually somewhat more, feasible, some more achievable. It's about how we have to sometimes reward the company to really capture the value from AI. So what I mean by that, right? First is really just create a strategy that is not based on fear of missing out. Just because everybody else is pursuing AI doesn't really mean that you should, right? I mean, maybe you should, or maybe you should on a much more limited basis, but your organization should really assess how does AI actually help us, in what conditions, and really start to develop a strategy for that versus just jumping in the bandwagon, right? Also, if you're going to do this in that strategy, you really have to think about kind of a dual timeline approach. One is about quick wins, right? It's about, okay, what can we get right now? But the other one is almost this quasi science fiction approach. We're saying, how is this going to evolve over time, right? How is this technology going to mature? How is these new models are going to come to life? How good are they going to be? How can you prepare organization not only for now, but for 10 years from now with the evolution of those models, right? So it's getting that vision, that imagination in place to really try to anticipate how the world is going to be 5, 10, 15 years from now. And of course, develop proper business case and metrics. Again, not jumping right into the bandwagon, but really figure out how are you going to assess this and how are you going to assess this quickly so we can pivot if necessary. The other big steps are related to changes in skills in organizing, right? Really figure out what are the skills that you actually need in your organization, right? Do we need people that are very technical? Do we need people that are really good in understanding how to use AI, right? Whatever the prompts that you see in front of you, they're going to figure out, right? Explain to people what AI can do, what it cannot do, how we need to be vigilant whenever we have hallucinations, right, or confabulations. What exactly is that you need, right? But a much more systematic, instead of let's just train everybody in AI and see what happens, right? Step back. What's the future of work in your organization? Then processes, right? Analyze your processes and absolutely make sure how can I combine humans and AI agents side by side here, right? What are my processes, my main processes? How do I figure out exactly what AI can do? AI is very good in patterns, it's very good in data retrieval, right? Humans are very good in empathy, in kind of deep thought, deep thinking. How do you have working them side by side in a way that really benefits my process? Most organizations just throw things in the wall and see what happens. Step back, look at your processes, really think about how they're going to change by the use of AI. And third thing, agility, agile, right? You always have to be iterating. If you have a new solution, you always have to be iterating, thinking about value streams, thinking about version 1, 2, 3, 4, 5, right? Because if you try to get anything else, either you are too disorganized, you even have an agile approach, you are trying to get superstructure, that is not going to work because technology and the use of the technology is advancing very quickly. Changes in data management and governance, right? Implementing data governance practices, really understand data repositories well, right? What is data? Which data do I actually have? Do I have high quality of data, especially if it involves IoT sources? And many organizations are not quite there yet. And essentially invest in data infrastructure, right? Invest in people who understand data, invest in the right technologies, that makes sense to your organization, because again, data is the lifeblood in a variety of different things. Okay. So finally, right, governance and risk management. Implementing AI governance structure, right? Have the right people answering questions, have the right people overseeing the projects, right? Making sure that the right people are in place to assess the risk of new initiatives. Create a responsible AI framework that applies to your organization. There's a bunch of responsible AI frameworks right now available, right? Many of the companies like Microsoft, Google, Amazon, and there are really interesting frameworks. Microsoft is a really good one, for example, because they are a developers company, right? So it's kind of, hey, our own responsible framework might be, a responsible AI framework might be helpful for other people outside the organization, right? And they might or might not be completely, right? So understanding how responsible AI happens, what frameworks you can use and adapt to your own organization so that you're always aware, right? That you have the right check marks at the right time, right? As you evolve your process. And finally, bring risk management early. I mean, that's actually the application not only for AI solutions, but any technical solution, right? Don't treat that as an afterthought, as saying, hey, I did this, I created this new solution, now risk people figure out how to actually minimize the risk, right? If you bring it people early in risk management, that means that you're always thinking about risk from the very beginning, and you're always thinking about how this solution can be deployed in a way that is not going to cause any problems later on, right? And that collaboration with risk management, right? It might be cybersecurity, it might be ethical risks or reputation risks from the very beginning, really means that, right, it might delay a little bit more the project, but to get the right solution in place to be deployed. Okay. And that is pretty much my last slide. Try to be mindful of the time here. So again, this is our QR code. If you are interested, this is for the MS ITM, our MS in IT management. So a lot of this content that you see here are things that we teach in our classes. I did a little bit of a tiny version of that. But if you are interested in AI management, leadership in tech, if you're interested in enterprise data architecture, security, those are all topics that we have in our MS IT management. We also have some coverage of AI in our MS in business analytics. And last but not least, we have the MS in finance as well, for those of you that want to have that perspective as well. And maybe open for questions, if there are any.
So I think there was a question before which you answered at the time.
I did, yeah.
Just in terms of, which industries.
Industries, yeah. So I mentioned that, right? So I mean, it's really widespread, right? It is just that most industries are struggling with the same exact factors right now, which is, I mean, the technology part, right? I mean, we see so many people, let's create let's teach you how to use ChatGPT, right? And then people, oh, examples, cool, right? Videos, well, great. And now the issue is, how do I actually translate all these nice technologies into processes? And that's where organizations have been struggling. I have been talking with a bunch of consultants, I have been talking to a bunch of companies that's like, okay, going from this magic of the technology to the actual practice, it's affecting everybody. So there's a lot of opportunities if you want to get into this area, right? LinkedIn had a study a couple of weeks ago about the most in-demand professions, and a lot of that essentially is AI consulting, right? Sometimes it's not the people that are going to do like the deep dive into technology, is how can we apply AI in an effective way in organizations. Thank you, Emilia, appreciate that.
No worries. That was a very interesting session and good to hear just about your courses, but also just the future of AI and what that's going to look like. Yeah, thank you very much. I don't know, Orlin and Alex, if you have any closing statements, if we have no further questions.
I don't, but Ali might have. I do have one final message, which is if you are, here right now, or if you are watching this and recording, that's great. You are on the right path, right? You are someone who's getting, to get more knowledge, getting better prepared to really be someone who has a very nice career ahead of you. So I appreciate you and appreciate your interest. Arlene, pass to you.
Thank you. I guess I'll say in closing about our programs. I know Alex mentioned off the bat that they are online. They're also highly asynchronous. And you also never need to come to the US at any point during the program. And with that highly asynchronous nature, it's very compatible with someone who might be on a very different time zone than the US. And we do have students taking these programs from all over around the world. And we look forward to connecting with you if you have any questions, additional questions about them. Thank you very much for attending this session today.
Perfect. Well, yeah, thank you so much to our lovely panelists as well for today's session, as well as those attending and those watching the recording. We'll be sure to also put any useful information in our follow-up comms, so you'll receive an email about that as well. And yeah, that's it from my side. Well, thank you so much wherever you are in the world watching this.
Thank you.
Thank you. Bye.
Bye. Thank you.